Hi everyone, this is MickMake mail number 37, which is pretty good, and I've got a couple of packages. Let's get into it. Hi, this video is sponsored by JLC PCB, who make all my PCBs. If you're looking for a quick turnaround PCB manufacturing house, then I highly recommend them. They can make 1 to 6 layer PCBs, and they've just reduced their prices of multi-layer PCBs down by 20%. So that's pretty amazing. And not only that, you can pick up a stencil for only $6. That's pretty low. So go and check them out. So the first one, I think I'll open, well, it's already been open. These were actually sent to my son. He found them on Alibaba or AliExpress or something. So it's just a bunch of small voltage meters. I don't know what the maximum and minimum voltage is, but I think we need to fire them up and see what they look like. So I've set my bench power supply to 5 volts, 100 milliamps, and I'm assuming this will be able to cope with at least 5 volts. But let's see, where's my negative? Okay, so I guess fairly accurate, 4.99 volts, and it's taking about, it's drawing about 8 milliamps. Okay, so let's just bump it up a little bit then. So I think I'll just solder these on semi-permanently. Excellent. Okay, so let's fire it up again. I'm still limited to 100 milliamps, but what I'm going to do is I'm just going to beef up the voltage and see how far we can go if it'll actually respond. So this is 6 volts, 7, 8, 9, 10, 11, 12, 15, 23. Can't remember how high my bench power supply can actually go. Yeah, 32 volts is a limit, so it can cope with at least 32 volts. And look, it's roughly accurate. It consumes about 11 milliamps. I might actually look these up and see if I can find them. Okay, so a quick Google shows up that they came from AliExpress, and they're pretty cheap, about almost $1 per unit. They claim that goes from 4.5 to 32 volts, and look, they're fairly decent for the price. They indicate roughly the correct voltage. It's out by 0.01, but hey, it's for that price. If you want a quick and easy voltage meter, then you can pick up a bunch of these. Anyway, there you go. On to the next thing, I think. Okay, so the next one came from the Netherlands, and oh heck, I can't find, where's my letter opener? Okay, for some reason I've lost my letter opener, so I have to use some medical scissors. So this is coming from Tindy, and oh, it's actually a Kickstarter. That's interesting. I need to look up and see what the Kickstarter... Oh, yes! So this was a Kickstarter I backed. Or it's a board that allows you to add a rotary encoder to it, and it provides an I2C interface, so it handles all the messy debouncing and other things, and also has LED control, so you can actually control an RGB LED, which is really nice. So Simon's written a whole lot of libraries that allow you to connect to it, and you can control a whole range of things. So that's a board. It's based on a PIC chip and provides a little I2C interface out, and you can daisy chain them too in an XY fashion, so that's really nice to be able to do that. So I think we need to fire one of these up and see how it goes. So the good thing about these rotary encoders is he's made it in such a way that you can daisy chain them. So you can have them like this, or you can have them if you want like this or this. So it's quite extendable. Having an I2C bus in this sort of format will cause problems. So it's better just to have it in one continuous run. But they're quite nice. Excellent. So you can see even on a Raspberry Pi it functions as advertised, and it's pretty responsive. So zipping through the numbers, it's pretty good. And of course, once you get to the maximum, I've set it to light up. You probably actually can't see it, but it's glowing the LED there once it gets to the maximum. So that's pretty good. Works on Raspberry Pi without issue. So I'm not going to bother connecting up to an Arduino. You would have seen it working quite well at Keen Maisel's place. So it's quite good on the Arduino as well as the Raspberry Pi. Okay, so on to the next one. I have no idea what this one is. Silicon Frog, excellent. So Steve from Silicon Frog contacted me during a couple of weeks ago and said he's got a nice little FPGA board that he's made and selling currently on Tindy, and so this is it. So this board's pretty decent. It's running the Lattice ICE40 LP384 FPGA, which only has 384 LUTs or lookup tables, so it's not huge, but pretty good if you want to get into FPGAs. It runs a 21 microamp quiescent current, so the LP of course stands for low power, and also when things are happening on the FPGA it draws around about 3 milliamps. So there's no embedded RAM, no PLLs, and no high drive output current on the FPGA, so it's a fairly cheap version, but it does have NVCM, which is Lattice's version of one-time programmable memory. So of course you need external flash, which is on the back here, and it's running 512 kilobyte SPI flash. It's also got an LDO on there, a couple of LEDs to flash, and a 16 megahertz crystal. You can program using the open source iStorm toolchain, and it's got headers on one side which are completely Pi compatible, so you can just chuck it onto a Pi without any issue and just program it straight from the Pi, which is nice. And also you can program, of course, using Arduino and anything else. So yeah, all 24 pins are broken out of the FPGA, which is good. So I think I need to fire this one up and see what I can do with it. Excellent. And I'm just going to chuck it onto my Raspberry Pi here. So the next thing you need to do is download all the software, the ICE40 software. This actually takes a fair while on the Raspberry Pi to download, compile and install. So just sit back and have a coffee while you're waiting for it to finish. Now they've got everything set up, it's just a simple matter of running an I2C scan. So it's coming up on address 42. Well, that's pretty good. It's behaving exactly like an I2C slave device, all in hardware. Nice. So the next one is one that I've been waiting for a long time. Ta-da! So this is a pretty expensive SBC. It's not something that you'd want to, well, it's a purchase that you'll really need to think about. I keep getting hit by this. So this is a pretty beefy little power supply. Okay, so just as I was unboxing it, there was a screw loose in here, which is a bit strange. It's just holding down the fan and the heatsink, but still it's a bit odd. So the LattePanda is a pretty expensive SBC. It's currently selling for $358 US. So if I were to buy this in Australian dollars, it would set me back $500. Fortunately, I bought this in US dollars, but even then, it's still a pretty expensive buy. But one of the main reasons why I got it, well, one of the reasons is to review it, but the other reason is because I've been looking for some time for a really cheap, small replacement for my Mac Mini that I use. So hopefully this will be a really decent replacement, something I could use to edit videos in the field if I need to, something that's a lot smaller. So hopefully this might be it. So I won't really go into this board in this mailbag because it's something that really needs a full video, a full review video. This particular board is the 864. So it has 8 gig RAM, 64 gig eMMC, runs the Intel 615 HD graphics, so it supports 4K at 60 frames per second on HDMI, DP and EDP. So you've got 3 interfaces. You got Bluetooth 4.2, not 5. 802.11 AC Wi-Fi, Gigabit Ethernet, USB 3.0 RTC, USB Type-C hub, and also, as you can see, it's got a USB Type-C power adapter, which is really nice. It's also got SD slot, dual M2 key slots, audio in-out, and it's got 2 50-pin GPIO headers, which are coming from an Arduino on board, which seems a little bit strange, but hey, I think for a board of this price there seems to be little need to have an Arduino, to be honest. That's my opinion. This sort of board isn't really a hobby maker board, it's more of a really a high-end pro maker type board, and they probably wouldn't be making use of these GPIOs, but I could be wrong. But really, the really nice thing is it's really, really thin. Look at that. They've even used an embedded Ethernet socket to reduce the overall thickness. It's really a very thin SBC. No bigger than any of the other ones you might see, but it's infinitely more powerful. It uses the same CPU as the latest MacBook. So the natural thing is to make this a really tiny Hackintosh. And that was my goal, to see if I could actually run Adobe Premiere Pro on this and be able to edit out in the field and have something really, really tiny. So you would have seen my LattePanda review, which I did some time ago, and I actually tried to get macOS running on that, but unfortunately I couldn't get that running. The support for Atom CPUs isn't really as good. So this would be really nice to get this LattePanda Alpha running with OS X. So that's good. And the other thing I'd like to do is be able to see if my Pi projector functions on this as well, which would be really nice. So one thing you have to know, that I actually purchased this board. It wasn't given to me as a review unit. So I had to fork out $360 odd US for this. So unfortunately I won't review this today. You'll have to hold on till the weekend to see what I think of it. So there's one other thing that I've got, which was another splurge, but it's another project that I've been interested in doing. So let's crack that open. So before I open the next thing, one of my other projects that I've sort of had on the back burner for a while is a Quartet Keyboard. So this is something that's about 15 years old, I think. And it's something I shelved because, I was busy and other reasons. So the idea was that I have 4 keys per hand, and I'll be able to press the buttons down and make characters out of it using a chordic input method. So I've always been fascinated with alternative input methods and outputs as well, and something that is completely mobile, something that I could carry around with me. This isn't really, but bear in mind this was 15 years ago, so I can make it a whole lot smaller than this. So with the Quartet keyboard, I went through a whole lot of different designs. I think this was one of the older designs. I then had this concept where it would have 8 buttons and possibly some more buttons up the top here, and a screen along the top. But it wasn't really pocket, I was aiming to have something pocket sized. This was yet another design. I can't remember how I was actually using it. Okay, it was certainly not like this. I think it was like this, and with extra buttons, so I could actually hold it like this. But once again, it's not, pocket size. It's all very complicated. I pulled apart an old keyboard. I think this is even earlier version of an old QWERTY keyboard, where I'd have this sort of slimmed down version and have buttons like this, where I could actually type. And in the end, I think I sort of went back to this design, where I'd actually be able to have something literally this thin, something with tactile feedback, so you know which button you've pressed, and very small, and you can literally put this in your pocket. And things have moved on, and now we have things like this. So this is one package I've been really looking forward to. So this isn't really a nunchuck, but a keyboard, which is pretty impressive. Oh, and one thing I just noticed then is that the case is actually the charging or the docking station, and you actually charge this case and it charges this as well. That's pretty impressive. Nice. So it's a little bit sort of fiddly to put on, which is one of the big issues I've had with it. So I've been using it for about a week now, in fact 2 weeks now, and it's sort of a little bit fiddly to put on. It's a fabulous idea, is that it frees up your hand completely, so you can pick up things, and it doesn't really limit the movement of your fingers or hands, so you can still be working away and type. So after 2 weeks of this, what do I think of it? It's a great idea, but there are issues with it. For example, this. Turning it on, turning it off is pretty easy. It's just a single button to turn it on, turn off. But as you can see, I can actually type in my password. Maybe I can type in my password, if I can actually allow me to do it. Yeah, so as you can see, it's a little bit impractical. Make lots of mistakes. It's a real bugger. Just can't quite get it sometimes. So as you can see, it's a real pain in the neck to actually type. It picks up extra characters, and you've got to type on a really hard surface, and you can't really type on a soft surface. One of the particularly good things about this Quartet keyboard is the learning process. So learning a new Quartet keyboard is quite hard, but they've gone to a lot of effort to actually get to learn how to do it. So you can do, I'm not going to turn it on, always helps. Come on. So they've got this this app that goes through a sequence of characters, and you can get to sort of type, and but as you can see, it sometimes gets it wrong. So that's one of the biggest issues with it. What I'm actually thinking of doing is, one of my next projects is to take my old, rather dodgy looking Quartet keyboard, convert it into buttons, and simulate exactly the same mapping that Tap With Us has, but have physical buttons. There's only a number of fingers, and so the way they get around using more than one finger is to have a space is one tap, 2 spaces is full stop. So I plan to have 3 buttons per finger and be able to control it that way. So that's another project that's coming up. It's not really a review of this thing. It's not really a maker product. but thought that might be interesting for you guys to see. So there's quite a few goodies. I'm really interested in getting more into FPGAs. I used to muck around with CPLDs and PALs back in the day, but I really want to get more into FPGAs, which is really good. And these are a great idea. I really like these, and I really can't wait to get into that review for this weekend, so stay tuned for that. Anyway, thanks for watching, and see you next week.